Welcome, everyone. Welcome to Ask an FDD Expert. We have David Landman, a guest speaker here, who's also a LBNL affiliate now recently. And I'm Hannah Kramer. I'm going to be moderating this session. We're going to wait just a minute more as people join, and we'll get started soon. All right, I think we're going to get started. We have quite a few people already joined, and other folks can join when they can. Again, I'm Hannah Kramer with Lawrence Berkeley National Lab. You all know me from the Smart Energy Analytics campaign, if you're involved in that. And now that the campaign's over, we're continuing our support of the EMIS tech team through Better Buildings. So this is one of our webinar series, and this one is going to be more interactive. You probably saw the email from us that we said, do you have some questions? We're going to put together a webinar with your questions. So the entire length of this webinar is just answering questions that came in from Better Building EMIS Tech Team members. So next slide, please. I'd like to introduce David Landman. We're glad that he's here today. He has a long history in energy and sustainability, and especially in EMIS implementation. He's implemented lots and lots of FDD systems, over 300,000 BAS points, various control systems in various sectors across the country. So he's got a lot of experience with the nitty-gritty day-to-day, how to get these things working. So we're going to draw upon that experience with the Q&A section. I would also like to say, if you have any questions during the presentation, please submit them through the questions box. And if we have time at the end, we'll add to our kind of Q&A as we go through. And the webinar is being recorded and posted. It will be posted on the Better Buildings website. You'll receive an email with the slides and with the recording link. So you can go back to that or share with others. All right, next slide, please. And I'll hand it over to David in a second. I'm going to just open up with the first question. This is a question that comes up quite a lot. We hear about, how do you prioritize things? What are the best practices for tracking issues from initial identification through resolution and verification? It's obviously important not to just find the issues, but get them fixed. So the question is, in many EMIS and FDD systems, it's easy to see what issues there are today, last week, or year to date, but it can be difficult to keep track of all the open issues and if the same thing keeps popping up over time. So David's going to talk about that. And this question was from Kevin Rogers from Brookfield Properties, and then we're going to unmute Kevin and do a little discussion. So take it away, David.
Thanks, Hannah. I'm going to share my webcam too. All right, so you see me in the flesh, so it's a little more interactive. So Hannah, thanks for that introduction. Yes, I've been doing EMIS for 25 plus years from the early days on, and I'll just say it's great to see the progress that's been made over the years in this area, and so many companies getting involved and so many people adopting it. So to answer the first question, for what Kevin said, there are a lot of different approaches to how to do this, depending how you look at things. Your EMIS should keep track of the issues and be able to give you a summary report. It's important to have a summary report so you know where you stand on how many issues have been are new issues, how many of them are older issues, how many of them have actually been closed out, because as you said, it can be overwhelming. So we want to know when an issue has been closed out. So some of the EMIS that we see out there have manual closing processes where you manually go in and you'll close out the issue based on seeing the data. And then it could potentially then automatically reflag if it happens again. So this is a typical approach for issues to be flagged and then closed out and then reflagged. And summary reporting can be done a lot of different ways. Some of them are done by building. So you have a summary of the number of issues that have occurred. You can also have summary reports based on equipment. Well, what are all the issues that have taken place in this type of equipment, or even issue type? So we've had a specific economizer issue. How many different air handlers have the economizer issue? So, and summary reporting can be very important, not just for closing out issues, but also for assigning work orders. So if you find that there's a specific kind of damper related issue that may be assigned to specific in-house people to address. If it's a programming related issue, this tag for that, you'll assign it to the BAS vendor to go through and change the programming. And also on large campuses, sometimes different buildings are assigned to different people as well. So someone could be assigned to one building or a group of buildings while it's set up to another set of buildings. So tracking with whom the work order is assigned to helps quite a bit. So how is it assigned for tracking? There are various ways to do it. One option is, depending on the EMIS, you can assign an issue number for it. So in the tracking system, there's an issue created. It could have the building name on it. It could have a type of equipment on it and a number on it. It's not a work order number, but this is an issue number. So this is an issue assigned to a fault that was found. And then you create a work order from that. When the work order is complete and it's verified, then it should also be verified it's closed, not just from the work order, but also in the EMIS. And it'll be closed by no longer seeing it flagging there. I like to wait for a little length of time, especially something like an economizer that's only seasonal, so it may not be flagging, but I wouldn't necessarily close it out until you can see it under the right kind of weather to verify whether or not it's occurred or not. So for recurring issues, there's also something to note that there's a finite amount of energy. So if you're looking at energy savings for it, if it's happened multiple times in a year, make sure you're looking at that equipment only saving so much energy from that kind of fault. Don't double count that type of energy savings. Also, if an issue occurs more than once, I would create a new issue number the second time it occurred, maybe a sub-issue number or something very similar, so you know they're related to the initial issue. Depends how best to keep reporting with your EMIS service as well as internally. And can this identify bigger issues? Big question is, well, what if we find a few things? Does it create an opportunity to find bigger issues? So I recall one site I was at, there were VAV boxes that had problems of either too much air or too little air. They were being identified with damper related issues, temperature related issues, and it was actually a much larger problem. When the O&M team went out there, they were discovering that it was a flaw with the design of the terminal boxes. There were these plastic wheels on there that were breaking. They're on metal, and when they're breaking the position. So it was actually a much larger problem. So, but the investigation from the O&M team, they figured out what it was, and then they were able to work with the supplier on a solution for all their VAV boxes. Let's take a look at some examples of reporting. Next slide, please. So here's one example from an EMIS provider showing issue numbers assigned. This is one of their reports. There's a lot more information out there with all the EMIS providers, but you only necessarily want to look at a small amount at a time. This one assigns an issue number, names for the issues, which could include a description of the problem, comments reported, and updates. Customer comments, so if a customer is also working with in your EMIS, then there's interaction in terms of communication. Communication is very important. So the latest update to the issue is also in the tracking with dates. There's a priority, so is this a high priority one? So you could filter based on priority, the ones that you want to address, savings or status. Some of them, if it's like an economizer issue, you may not be able to see it during the winter time, so you may want to change the status to to wait until next season to look at it, make it seasonal or something different. They can be sorted based on building, issue type, priority, and status. Next slide, please. This is another example. This is more like looking at all the information at once, though. A lot of you may be familiar with this. This is a Sky Foundry example of what they show. So this kind of shows the frequency of the fault and tracking it over time, so you can potentially see repeat occurrences. If you look somewhere, if you look in the middle, that red, that's the reheat valve leakage or DAT miscalibration. It looks seasonal, that it's not occurring for certain months, or it probably was never corrected. But also the fact that it's no longer occurring with changes, weather and other operational changes. So just because it looked like it was closed here, it's occurring again. So this is one of those that could either be a continuation of it or a repeat one. It would probably require a little more digging to find out. Next slide, please. Here's an example of a dashboard tracking. So on the higher level, you want to know what's going on in your site. So if you look at the bottom right there, there's an impact. There are 113 completed tasks. Well, you want to know what they're working on. If you can see that with the energy impact, there are 34, with maintenance impact 98, and with comfort impact 81. Well, there are only 113 of them. So clearly, when they were addressed, it impacted more than one of the things that you're looking at. Energy tends to be the most important, but comfort and maintenance impact are important as well. Next slide, please. Oh, I'm sorry. Question actually for Kevin. Can you share briefly about some of your practices that you use to track issues and flags or sparks? What's your procedure of how you do it right now?
Sure. Can you hear me?
Yes.
Okay. So yeah, we use we have about 90 properties on SkySpark. And we are Brookfield Properties Retail is a owner of malls across the U.S. So we have a Niagara-based EMS system with SkySpark overlay. Unfortunately, we're pretty advanced on the EMS and FDD side. Unfortunately, we've never gotten to the point with a CMMS system, so we don't have a work order system. So with that many assets, it's a challenge. We've tried the tracking and spreadsheets, and we've have a master systems integrator that we work with that develops the Spark rules in SkySpark, and they've implemented some tracking apps within SkySpark to assist. But overall it's still a challenge. I mean, it's like everyone. We're kind of understaffed for the size we've got. We're just trying to make the best impact we can. We do send out weekly reports to our operations staff at each property, as well as a monthly larger kind of KPI report for VPs within the region. But at the end of the day, it's still difficult, and I've seen this at other installations outside of this company, where it's hard to get everything to resolution, to closing out an issue.
Right, because you, as an old boss used to say, is it done? Is it closed, essentially? So it looks like it is, but is it really, based on the data? So, and there are judgment calls based on that sometimes. Sometimes it's very clear, other times it's more of a judgment call. And that's part of the nature of the beast, because we have sensors that may be slightly calibrated off. So if you see something, and that could help you actually calibrate your sparks. So if you have issues that are sparking with like a 2-degree difference, maybe they need to be raised to 2.5 or 3 degrees so they don't show up as frequently. So part of it could be calibration as well to help reduce that.
Yep.
But I feel your pain. It's not an easy thing. There are so many people, so many different ways of looking at it. We all want the same thing, but you have somebody who's looking at the sparks, someone who's looking at the work orders, someone who's physically there, and it's a question of all communicating and talking the same language.
Yep.
Thank you.
I think we'll go to the next question, which is a bit of a follow-on question from Kevin. Case studies are best practices in flagging maintenance needs. So, you know, we have these energy, maintenance or comfort issues, and now talking specifically about how to do more proactive maintenance.
Right. So another good question. They were all great questions that came in, by the way. So the EMIS should be able to identify what type of maintenance required. As I mentioned beforehand, if it's potentially a BAS programming issue, or if it's O&M measure, if there's good root cause behind it, you should be able to determine what that is. So with physical, some EMIS systems may filter rules based on an FDD type. Is it O&M? So if it requires a replacement of a part, if you have an actuator or filter that needs to be replaced, it should help be able to identify that specific measure so you can give that as a work order to your O&M group. And then there are changes for sequence of operation, which can be another one to find. One way to do this, again, sites have different people working on different buildings, so flagging which building is also useful. As you mentioned, you have multiple locations, so if you have one person looking at all of these, you want to make sure you're assigning the right people to look at it. So this could require manual tagging, so we want to make sure it's the right equipment, the right person assigned to it, as well as the right building. And the root cause will help that. But there's a caveat to this, which makes it more challenging. What's really important is to keep in mind the importance of tagging equipment with the same names throughout the process. So throughout what I've seen, when you have a vendor come in, they program your controls in their building automation system to operate a certain way, and they'll name an air handler a certain way. So they could call it AHU1, or they may have a name with the building attached to it also. I've seen one provider actually on the same campus, depending who programmed it, would either use the abbreviation of the building or the full name of the building. So you want to try to be really consistent with the tagging of the equipment. And then the equipment in the work order system, you want that to be consistent as well. The EMIS system will also require the same consistency because you're all talking the same language. So the best practice for flagging maintenance is making sure you're talking the same language. Sometimes it involves naming a piece of equipment two different ways. I've seen that too, or put a little dash like the area that it's served to help with multiple names of a single piece of equipment. Next slide, please.
I'll just chime in quickly that we do have a couple case studies from the Smart Energy Analytics campaign of folks that have really focused on reducing their hot and cold calls and more proactive maintenance. And that's from University of Iowa. We have a case study, and then also from Emory University. So I will put those links also in this slide deck, so you have that to look at. And you know, basically they're just trying to get ahead of any zone level issues, and instead of, you know, servicing by hot and cold call, they're trying to find issues before they get those hot and cold calls. All right, next slide, please. All right, this is a unique question about vertical transportation systems in FDD. What do you think, David? So
it's not as unique as you might think, but it tends to be looked at differently. I actually recently found an example of an EMIS provider who was at an airport, and they were monitoring the downtime of elevators, escalators, and walkways there. So they do it indirectly. So they basically take the motors and they want to know how often things are on, and if you have a variable speed drive on it. What's typically done is actually more the HVAC in the mechanical room serving the elevators. So it depends on what data is available. If you can pull it in, you can add an FDD to it. So if there are alarms that are available, motor data, if you can attach to the panel, you can provide an FDD rule for it. There's no reason why you can't add it in. But are there a lot of them out there that look at all that? Probably not. But I did find one the other day that looked at airports. So it is out there.
Great. That's a good reminder. You know, you can make a rule for anything and just want to know what you want to keep track of. Okay, we're going to keep it moving. Next slide, we're going to move on to some questions from Jerry Gallegos at Cyndia National Labs, who also has an FDD system. He asks, we're having challenges getting our O&M team to embrace FDD. This is very common, and until you get over a certain hump, so we hear from lots of folks. So what are some best practices to get over that hump and make it easier for folks to embrace FDD?
Yeah, great question and very common, unfortunately. So I think the first thing to do is kind of set the right context, have the leadership provide the right context for it, help with the listening to what people think they're getting and how it can help them with their own work instead of adding more work for them. A lot of the O&M teams, they're overworked, they have too much to do, they're constantly putting out fires. This is actually going to reduce the amount of fires they have to put out because you're doing more predictive. There may be a little more work up front, but once it gets going, it provides more time for them to focus on other things. So make O&M more predictive to address before there are major problems. Another is to provide more contact. Meetings are important. Periodically discuss lists found. So potentially, at least at first, be part of weekly meetings or monthly meetings, so everyone's on the same page of how to conduct meetings, and what they're looking for, and how you can be resourceful in helping each other. There's a lot of data available through the EMIS, and the key is to use that data to save energy, save O&M, and to save time also. You let the data work for you. Decide who has ownership of the issues, who's responsible for completing the task, put it into the work orders and closing it out. Give the individuals the authority to accomplish things. Sometimes people say, well, it's a lot of data, but I can't do anything with it. So they need to be able to have the authority to actually accomplish things. One site that I know of has a system where the EMIS operator provides a list of issues to fix on a monthly basis, and they have a follow-up meeting to explain the issues. They actually look live at the VAS at times to determine next steps, including writing the work orders. The EMIS company adds the work order number to the issues for tracking purposes, and the O&M group closes out the issue and provides emails both when it's been assigned as well as completed to the internal groups as well as to the EMIS provider to know when it's been completed. Then the EMIS service provider determines if the work is complete, though, from looking at the data. It's always about the data. It's not just about saying it's open or closed. So the key is to getting enough clarity to have that work properly. And as they get better over time, it takes less time to actually have these conversations, and it's a much smoother process. You have to provide the tools to be successful for this. And the work order system is one of those tools. Accessing the EMIS issues discovered for feedback by the EMIS service provider, control, contractor, O&M and energy group, have them all working together. Incentivize savings. Some people incentivize savings to provide at least recognition. You saved all this energy in the group. Who doesn't want to show fewer alarms year over year? Where all these alarms going? People don't want to get dinged from alarms popping up. As part of the process, you get fewer alarms and more savings. You get energy savings, lower carbon emissions, and more reliability and longevity of the system. So, Jerry, can you share more about your specific challenges that you're facing with getting them to embrace FDD?
Yeah, can you hear me, David?
I can hear you. Yep.
Yeah, great. Yeah, great. Thanks for answering the question. So, so you really nailed it on our challenges, and you gave me some great ideas to try to solve some of our issues. But our maintenance folks are just overwhelmed, right? They're overwhelmed with reactive type maintenance, correcting issues, alarms, and they just don't have the time to look at the data and time to focus on the FDD. So so I like the idea of setting up a meeting, maybe a weekly meeting, just to meet with the O&M team to take a look at the faults and go through those, so we can focus on that. Another thought I had was maybe having them look at the faults first thing in the morning before their day gets started as a routine. We've kind of given them the tool and the data, but they haven't built it into the routine. So those are some of the challenges we have.
So another thing around that is, do they have the skill set to fully embrace and understand the data they're looking at, or is it easier if it's brought to them a different way? So some of the people might, some might not, depending.
Yeah, that's a great point. We found that you know, I want to say maybe a majority or most of the O&M staff don't have the skills to analyze the data. There are a few that do, but again, they're busy, right? And they would like to spend more time in it. We were thinking of maybe getting a dedicated staff or a dedicated team together that could just focus on the FDD and get them well trained. So we're thinking about that too. What are your thoughts about that? Getting just a few very well trained and have them focus on the FDD.
That's a reasonable thing. Or if you have one person who can put it in a form that's easier for them to understand. So instead of them looking through the faults, that individual presents it in a reporting way that helps them determine what they need to look at. So it's somebody who translates it. Actually, can you switch to the next slide? So I kind of look at the team approach to things, which I mentioned, between ownership, facilities, EMIS, and controls. So you need to make sure that everything, you're speaking the same language to each other. The building facilities group, they're the key, the core, because they're the ones who go out and fix everything, the O&M group. But they have to work with your EMIS vendor, controls vendors, and ownership has to give them the ability to be able to succeed with it. So in your case, does it involve having an individual in the facilities department or O&M group that understands EMIS? It might work better that way for you. It's certainly worth a try. But that's why I suggest having a meeting so the EMIS provider can actually talk about how the facilities group needs it explained. Some EMIS people are data people. Some of them, like myself, have a background of physically being in, looking at equipment, saying, I know you probably have a sensor in the wrong place because there wasn't enough room for it. I get these problems. Let's figure out a right solution for it instead of just looking at the data and saying, well, you can't do that. So you need the right people to understand it.
All right, thanks, David. I think we'll go to the next slide. And we do have a number of examples of folks we've worked with through the campaign that did hire a point person for dealing with the FDD, and they became the expert user. They actually would rove and train each site as they went along. So they might spend a year at a major site, get people up to speed, and then move on in a training mode. So there's that has had a good success for people. All right, next question. Is it benefit to integrate work order systems for tracking? This is a big question because it does take some cost to integrate with work orders. So, or is it better to keep track within the analytics tool itself? Best practices on workflow in general.
So I think this is really site specific. And Jerry, what you mentioned, potentially having an individual who can write the work orders, who is kind of draws the difference between the EMIS and the work order system. Let me give an example of workflow. So the EMIS identifies issues to address. Let's say an air handler with a passing preheat valve. The EMIS vendor provides monthly calls with the client. The client takes this and other issues identified on the call and creates work orders for the air handler, preheat valve, and others. The EMIS provider then receives the emails, which I mentioned before, from the work order system and indicates that the work order number and date that's been issued. And the issue is not closed out until it's completely done. The thing is, to actually, you can integrate it into the work order system, but if you do that, the person who's writing it is from the EMIS provider. Are they going to write it in the right form of language that really enables the O&M people who have to work on it to be successful? So I've seen more success for you have a person in between writing those work orders, yes, it could get lost in translation a little bit, but the person writing the work order understands what has to be done. And the person in the EMIS is working from a data driven. So they have different purposes. Does that, I think that's, it's a common question. It's similar to what we were talking about before.
Great, thanks, David. We're gonna have to keep moving because we're a little bit behind. So I'm gonna go next slide. Good metrics for tracking thermal comfort. You want to talk about some metrics piece, and I think you have a few examples here.
Yes, thank you. So there are a couple of examples here on the right. This is actually from one of the BAS providers, Automated Logic, and EMIS providers have this as well. So the main things that people are looking at are creating reports from different types of IOQ. If you look at the bottom right, it's maybe a little hard to see, but temperature is very typical in zones. So this is reading 72 degrees, and there's a range of 66 to 74 degrees here. So you're looking at a measurement of, 68 to 74 degrees. So how many zones are within that range and how many of them are out of that, and to give it an overall. And the same thing with relative humidity, if you have RH sensors that you can monitor. Carbon dioxide is another one. This is showing 600 parts per million. In this specific example, they have a range of 400 to 900 parts per million. There are other ones out there for particulates and VOCs as well. So those are available, and as indoor air quality and healthy buildings become more important, there are more things available. As long as you have the sensors, you can actually add them all up and get an overall score for indoor air quality.
Yeah, and obviously with pandemic mode operations, that's becoming more important, as you know, CO2 can be a proxy for your indoor air quality in your space. All right, so we're going to move on to our next question. This is from Martha Larson at Carleton College. So setting up a campus-wide EMIS system has allowed them to see their meter data in a way that they could assess which meters weren't working, weren't set up right, lots of issues. So what steps should people take to be a part of a meter connection and commissioning process, and a scheduled checklist for ongoing maintenance of those meters?
Thank you, Martha. Great question. Meters always have issues. When they're connected, the key is to check the data for changes. It's not just the initial, but the changes over time and what the expected values are for calibration. You can compare some with temporary meters also. Meters and all data for that matter really needs to be checked on an ongoing basis. To be able to accurately indicate what's going on, you have to have an ongoing monitoring of the data itself. So one of the issues is when meters turn over. Did the meter collection in the EIS or EMIS do a good job with the data correcting when it turned over? So if it was going up to 1 million and then it turned back to 0, how is it doing that? Is it showing negative results, or does it know what it's doing? We have daylight savings time coming this weekend. Does your EMIS know what to do with that 1 hour difference? Another example is verifying how meters are performing under high or low loads. Steam meters, notoriously, if they're sized for a certain range steam load, that if it's under a very low load, may not be accurately indicating how much steam is going through there. So I'd focus on the steam meters as a potential issue. Flatline data. Are you continuously checking the data for flatline? This may be an indication that there's no consumption or that the meter is having a problem with the data collection, but not the meter itself. So setting up rules to flag flatline data, null value, there has to be there can be an indication of communication issue with the meter. There needs to be investigation of what's going on. So follow-up question, Martha. Which of these issues you listed were the most prevalent when you set up your EIS? Was it wrong calibration, wrong gains, wrong units, faulty BAS, or something different?
Yeah, I think we use the Lucid Building OS system to get a good data visualization. And so we do get good flags for flat lines. We get good building comparisons, so we can see if a building is an outlier. So most of our issues are actually with the meter selection and install, which is selecting the right meter for the right range, for the right pipe size, and then installing it in a way that, the probes are positioned in the exactly right spot. And so we've been using a commissioning agent to sort of go through those one by one, but he finds a lot of issues. And so my question is, like, is there a good checklist we can give to the contractors so we don't have to retroactively address all those issues? We can get it right the first time. And then also, how often should we be calibrating meters? If they're working pretty well, should they still be calibrated yearly?
So as for calibrating them yearly, I think that would depend on how big a range and how accurate you need in terms of the data. So if you're sub-billing, or if it's off by 0.5% or 1%, is that going to make a big difference to you? It should be calibrated as often as the meters are recommended by the manufacturer, but I know that most people don't calibrate things as often as they're recommended. So you may look at a drift, and you could do comparison year over year to see what that is, or do some kind of maybe a few a year and see how much they actually drift versus what's recommended. So just do a check on them. I wouldn't do all of them necessarily, but just at least a fraction of them, see how much of a change you really have. And the same thing for the meter sizing. I think in the location, if the manufacturer provides pretty detailed, I'd have a good spec out there for them to be able to provide that information of where they put it, how far down, to make sure that it's accurate.
So just read the documentation.
Yeah, it's part of the process of project management installation. You have to have as much documentation as you can and provide it. Make sure there's a good checklist for them to go through. So are you providing that to them, or who's providing that list?
To be honest, yeah, the engineer specs the meter, but then we're kind of leaving it up to the contractor to install, and the commissioning agent comes after the fact with a checklist. So we probably need a proactive checklist. It's a good idea.
Yeah, possibly doing it proactively and in reverse, making sure the engineer and the manufacturer have that as part of it, what they recommend, so that the commissioning agent can work with that. Good commission agents have a pretty good checklist, but maybe they're not looking at the right information.
Or you give the commissioning checklist to your contractors and make them do it. Okay, we're gonna have to move to the next question, which is also from Martha. What's advice on the top 5 faults? And we did organize this one by, yeah, Martha has meter data analytics, but we also are going to cover FDD as well.
Right. So I'm going to go through a few slides with this. The top 5 are typically site specific. Generally, things that revolve around safety are the most important, followed by energy consumption. However, there could be certain code ones, or even comfort. If it's a dorm or a hotel, they're going to be more interested in the comfort in there. So let's go to the next slide. I'm going to do a little quicker. Apologize, but this is a list of top ones found from the campaign, the top 5 in terms of EIS and FDD. So you can see from the EIS, a lot of it's scheduling, things that are left on, things that you find at the high base load or demand spikes. And then from an FDD point of view, it says simultaneous heating and cooling, but that can be caused by a lot of things. It can be leaking valves, it can be programming, but that's generally the biggest energy one. That and economizers are the 2 big ones that you find in terms of energy savings. But from the campaign, we have a good list of what they are. I'm going to speed up just a little bit because I want to try to cover as much as I can. No one objects to that. So let's go to the next slide.
Next slide. All right, this is a great question. When justifying a separate software system for meter data management, and so an EIS, what can it do that just having a BAS, your control system, cannot?
Right, great question. So the EIS is focused more on the meters. It can tell you things like heat maps, if the electricity or gas use remains high outside of occupied hours, but it doesn't pinpoint which equipment is on and just how much energy is used from each individual piece of equipment. It can do comparisons versus temperature, but again, it doesn't provide the same amount of information. On the previous slide, you mentioned specific faults. It doesn't tell you the simultaneous heating and cooling, but it can tell you start-stop schedules and high base loads, things like that. So you can set up trends in the VAS, though, to potentially do some of these things as well, but the EIS will tell you more analytics around it. The VAS it's really designed to provide control of the equipment. So it gets data, and then it tells it to start, stop, to increase temperature. There are alarms in the VAS. If temperatures get too low, like freeze stats or filter alarms. But it doesn't run analytics to determine what occurred to create that condition. So the FDD is really for the faults in the equipment operation and programming. And they're also geared towards energy safety and comfort. It's more so even the safety. It's not an alarm. It actually tells you a little more detail. Next slide, please. Here are some more examples looking at patterns for the EIS. Just give you a few examples. There are various different ways of looking at things. On a weekly basis, give you a range of what the pattern is, the range, how much consumption, peak, and base loads. Next slide, please.
All right, so we're moving on to Edna Lawrence from Beaumont Health. They purchased different FDD and EIS software packages, and we hear this a lot, that energy analytics seem to have taken a backseat to FDD. Suggestions on how to integrate the EIS and the energy analytics review into our FDD review.
Great. So this is kind of builds on the last question. We're looking, energy analytics looks the top-down approach, and FDD looks at the bottom-up approach. So if you do energy analysis with your utilities, perform a regression analysis and look holistically how your building's performing, as well as how each individual building is performing in a portfolio. But not everything may be connected to the EMIS FDD service. So being able to look at the building data helps quite a bit. You can normalize to weather, patient counts, for example. You can add value to where areas need to be for additional help. I even have an example from my grad school days many years ago. I was looking at K through 12 schools, and we had indices created for typical electric load factor. And then there was an occupancy load factor and people load factor. So when people were going in, the occupancy load factor was 1, and the people load factor was a variable, what percent of occupancy. Maximum occupancy was 1, minimum was 0.1. So one of the things I found from this, having those 3 indices, was the buildings were occupied during the summertime, but the electric, very little occupancy during the schools during the summertime, but the electric load didn't drop. And it was actually based on the humidity requirements. They had to maintain low RH, otherwise they'd have mold issues. So looking at the energy analytics was able to tell that. What metrics can you compare it to? Number of patients in a hospital, manufacturing numbers, gives you a little bit more of an idea of how your building or facilities perform. So as a follow-up, Edna, what kind of energy analytics are you currently using, or do you have available? Are you using heat maps, load shapes, EUIs? What do you use?
Oh, sorry, I was muted. So we're currently mostly looking at heat maps. A regression analysis was, a couple years ago when we issued our RFP for our monitoring-based commissioning program at Beaumont. We did want to look at regression type analysis. I'd say right now, though, that the heat maps have been the most useful piece of information, and but we do have, on our Royal Oak campus, which is our largest hospital with multiple buildings, we do have energy consumption broken down by building. And so it is interesting looking at the heat maps, but I'm just finding that we're not necessarily right now connecting the dots between the FDD faults that are identified at specific buildings, and then the energy consumption, you know, we're not necessarily seeing that shake out. And so, really bringing that back together, I think in terms of even getting buy-in from the facility staff to say like, hey, what you're doing and by addressing these issues is actually making an impact. It's just something that I feel like we haven't quite connected the dots on yet.
So have you gone into specific buildings, like if you have a heat map for a building that's much higher consumption or outside of certain hours, to have somebody inspect that even further, deeper into those buildings?
Yeah, it's in kind of our action plan right now. But at the same time too, this is a hospital system. And so a lot of our consumption or our usage is 24/7. So we have patient towers that show very little variation in the heat map, but to some extent that sort of makes sense because that's occupied 24/7. Lights are always on because it's an ICU tower. So, there's nurses going in and out of those rooms 24/7. So it's yeah. So in a lot of ways, like the heat maps make sense. That and like the ICU tower is pretty consistent, and the research building, which has more of a 9 to 5 schedule, looks 9 to 5 in the heat map. So I guess there hasn't been much in terms of red flags that we've seen that way. But yeah. So I think looking at how we can map reduction is more so where we're trying to go.
And Edna, we can also follow up with you online to talk more about the regression analysis, which may have had a COVID influence on it in setting your baseline and things. So why don't we follow up with that? That's a really good point on connecting the two. Okay, next slide. Network speed issues. What are creative solutions to pull data out of the system without compromising network functionality?
Great. So this is not an uncommon thing. So the key is to addressing the number of points that you're monitoring and the frequency of the points that you're monitoring. So example, if you're polling every 5 minutes, can you poll every 15 minutes? And I'm not talking about all the points potentially, but having a smart EMIS provider can determine which points. Do you need all the points polled at the same frequency? If terminal devices make up 75% of the points you're polling, do you need them all the same frequency of the air handlers or plant equipment? Maybe you can poll those every 30 minutes. There's a limit to how far you want to go though, because the analytics don't work as well. So I would say 15 to 20 minutes, 30 minutes at the longest, because you'll lose some of the granularity with that. Or if you have certain points, so you have a command point and a feedback, a signal and a position point. Do you need both of those to verify the feedback? Maybe you could just take the signal point. Can some of the equipment be pulled less frequently, like every other week? Is something used all the time? Do you need it to be pulled? So by doing this, you're actually changing the overall number of points that you pull over a length of time, and it should reduce the taxing on the network. So don't let slower networks prevent you from implementing a successful EMIS. As a general rule of thumb, for legacy systems, 15 minutes or even longer, or even rotations if you need to do that. For the newer, more robust BAS infrastructure, 1 to 5 minutes. 1 minute's typically not needed. I mean, it does show more oscillation, but there's a tremendous amount of information that can bog things down. So I would use that less frequently. 5 minutes should be able to get you enough information. Next slide, please.
Okay, so the next slide is about how to decide whether to put out another RFP. You have your system, you're thinking about expanding it. How do you decide? What factors should you consider in deciding to potentially switch platforms, and what are the sort of potential pitfalls of that? This is a big question, so we're going to have maybe just a cursory answer on this one, David, in the interest of time.
Right. Yeah, so it's basically defining your current needs: energy savings, cost of service, you're looking for a healthy building, define what your needs are. That's what I'd recommend doing. Once you define what your needs are, then you can define who best fits that, if it's your current provider or someone else.
Okay, next slide. Rules of thumb for estimating cost savings beyond energy savings. You want to talk quickly about that?
Yeah, so there are a lot of savings out there. I'm going to mention, just because we were talking about healthcare, that I got this out of Energy Star. This has been around for a while, that hospitals, for every dollar a nonprofit healthcare organization saves on energy is equivalent to generating $20 in new revenue for the hospitals, or $10 for medical offices. Now, I still thought it was a lot, but that's out there in Energy Star. By saving energy and being more efficient in terms of operation, you make everyone else more efficient. Let's not for healthy buildings as well. So we're looking for healthier buildings. You're bringing more ventilation. You have what's $1 of energy as opposed to $20 per person. You have a more efficient way of delivering the heating and cooling to individuals, and you make them more productive. So as for individual faults, it depends. Unfortunately, you can't look at a small piece of equipment versus a big one and say, well, the big one's automatically going to be the one that's going to save more, because that may have a very small simultaneous heating and cooling, where the small piece of equipment could have a large one, and they, in terms of constantly heating and cooling, and the savings would be about the same. And also economizers, depending on what part of the country you're in, they may only impact you for 3 to 6 months of the year for potential savings. So they're very big for those months, but not so big at other parts of the year. So, and the equipment life cycle cost, if you're reducing oscillating dampers and valves due to poorly tuned PID loops, you're helping the O&M group. You don't want to spend the money on replacing those, so you elongate the life of that. So, and overall savings, though, can be pretty significant, like 5 to 20%, depending on a lot of factors. And the systems typically pay for themselves, according to the campaign, in about within 2 years.
All right, that's great. We're going to skip a couple questions. We're going to skip to slide 25 in the interest of time and talk about cybersecurity and working with IT.
Great. So tips on educating. So get IT on board early to support the EMIS setup regarding IT networks, data transfer processes, and network cybersecurity. Ask their security requirements and process, and confirm with your EMIS provider what protocols they follow. Explain it's about pulling data, not pushing it. So a lot of IT people don't want to see the data being pushed into the network. And also remind them, in a lot of cases, your VAS network and the data you're taking is probably a separate network from others on site. So there's no security risk. So there are basically 4 steps involved with doing this. And I suggest looking at the EMIS specifications of procurement support material as well. But conduct a cybersecurity review of the EMIS system. Design cybersecurity approach, identifying security boundaries and select security controls. Implement cybersecurity framework and protocols as designed and agreed to, and maintain system to meet cybersecurity needs, which could change over time. How will it be monitored and maintained to address evolving security needs?
Okay, that and I again would point to the section. There's a cybersecurity section within our spec. You can get some language on that and some of the planning around that. David, I'd like you to talk about show on slide 27. So go 2 slides more, and we'll kind of end here with some examples of the big picture summary. Again, from the question earlier, how do you prioritize? How do you see the big picture within FDD?
Right, that's a great question. So the key with the FDD is your prioritization of how do you define high. And each EMIS provider is probably a little different. I would suspect most of them view safety and energy as the main ones, though. So another one is defining high as larger pieces of equipment. If you have VAV boxes that have problems with them, you could have hundreds or thousands of boxes. And I've always found that that tends to be the lowest on the totem pole unless it's serving the president's office or someone really important. So I would focus on the bigger pieces of equipment, the higher savings, and the higher safety. And this is an example of one of the dashboards that's available for a specific building. So when they define what you consider high, medium, or low in terms of their rankings. And but I think it's important for you to have a little input into that. But I think if you look at most EMIS providers, they're going to tell you the same thing, what they look at for the highest value. But remember, they also cover everything. So once you get through all these, there's still the other set of equipment to go through as well. So that's the advantage. You focus on the big stuff, big ticket items first, and then drill down later on.
All right. We just have a few minutes left, and I actually want to get to, we're going to wrap it up. I want to get to the poll. So go to slide 32 for a second. I'll say that here are email addresses if you have more questions. For those that we didn't get to today, we'll follow up directly with you. And we want to see what you guys want to do for the remaining of the fiscal year. We're planning our webinars and interactive roundtable kind of things. So once you launch the poll, Allie, and help us plan for the future. You can check multiple boxes here. We have some ideas. You can also email us additional ideas that are not on this list. Getting the most out of the EMIS you have. An EMIS 101, maybe for the folks that are just getting started, need to know the terminology and the capabilities, the process, monitoring healthy buildings. That's real front and center focus these days. Another Ask an Expert roundtable. We could do another one similar to this with the back and forth. I thought that was great. Really liked hearing the voices of you folks out there. And then Internet of Things and EMIS, what does that all mean? So these are the ones we thought of. If you have different ones, please send us an email and we'll get those on the potential list as well. We're going to leave the poll open for just a couple more seconds. And it looks like we're getting the most out of the EMIS you have is a little bit in the lead, but everything else is very high as well. So it looks like these are all pretty good. Can we publish the results here a second? There we go. Okay, so the EMIS 101 was a little lower. That makes sense because you guys are all more seasoned in this, getting the most out of the EMIS you have. And IoT were the highest. Okay, next slide, please. Thank you so much for that feedback. And I wanted to, next slide, remind everyone about the campaign toolkit. We have all this data, we have case studies, we have the information now after all these years of research. We want to get it out there. If you have special cases where you need, for a presentation, you need us to come and present the results of this, let us know. Next slide, please. We also, through Better Buildings, there's a COVID-19 Resource Center, which has a lot of information on it. I pulled out a couple webinars, which are particularly good. One from December 7th about operations, and LB&L staff member had a really good presentation on that. And then a really recent one by an ASHRAE fellow on how the HVAC guidance has evolved. So it talked about, the original ASHRAE guidance was one thing and now it's this. It was a really helpful webinar to see what the current recommendations are. There's also additional webinars coming out through Better Buildings. Through this, you'll find information about that at the COVID-19 Resource Center. So with that, we're at the hour. I really appreciate your involvement and attention. Send us more questions. If we have another roundtable, we'll get those in there. And always feel free to reach out to us. We can have a one-on-one conversation about your EMIS questions as well. Thanks again and have a great day, everyone.
Thank you.